So
Yeah.
just save it. All right,
Okay.
sounds good. So yeah, I wanted to know about the project Babbage, and I'm really into this SPV thing. Like I feel like if we want to scale Bitcoin, we have to start, using SPV protocol and start building things on top of it. How are you doing that on Project Babbage? Is it so? I was reading your message here, and I understand that yes, it's a peer-to-peer, but then when it's connecting to on-chain, it's gone through the Bridgeport bridges, correct? And Bridgeport has that possibility of filters, and it can do the filter. So I want to ask, like, why do we need? So for example, say we're talking about the Convo, the messaging app, right? So if we can build like if we can build a peer-to-peer messaging via the SPV, just get the Merkle proof from on-chain, where does the Bridgeport come into the picture?
Well, it's really an overlay of sorts. I mean, so until recently, we really didn't have a clear definition of what is SPV protocol. And so part of what I've been doing the past few months is actually getting that defined so that we even know what it means to be SPV compliant. And so I think one of the things we settled on is transactions being exchanged, or rather the information aspect of a transaction being exchanged between two peers. And additionally to that, the involvement of Merkle proofs to ensure that that transaction is sort of anchored and legitimate as part of the honest chain. And the attestation by miners that any unconfirmed transaction will in fact be included in the next block. So those are what I would kind of define as the elements of SPV and what that means. But in the context of applications like Convo, if you think about the ramifications of transaction exchange, if I create a message transaction, right, that transaction can have multiple inputs and multiple outputs, and it can be doing a couple of different things. Firstly, it would be paying a commission to the message app. So like if I'm using Convo Dark versus Convo Lite, the transaction could be sending a payment output to the creator of that app. The transaction could also be, of course, containing the message or the encrypted copy of the message, or maybe just the hash of the encrypted copy of the message. It could also contain maybe what's known as a UHRP advertisement for a file. So if I want to have a file as part of that message, it might contain some additional protocols there. There's the action commission. So my point is that one single transaction can contain and represent different things in different contexts for different people, and not everybody wants to have to be able to parse and deal with every aspect of every transaction every time they're involved with somebody, because there can be multiple things going on inside of transactions. I mean, one of the things, for example, with that is sig hash. So you can do these building blocks where you sign with, I believe it's sig hash single, and you basically make a modular thing that can be added to any transaction that's also modular, and you can kind of construct transactions in that way. So the point is that in these cases like Convo, where what you're really doing is not Bitcoin layer, it's a layer above Bitcoin, not layer 2, not like Lightning or anything, but it's an overlay is the right word.
Yeah.
Where you're ascribing additional meaning. You're not trying to subvert the original meaning like Lightning does with BTC, but what you're doing is you're ascribing additional meaning. You're saying, well, on top of this being a Bitcoin protocol compliant transaction, there is additional things such as a message being sent between two users, right? That's not something Bitcoin's concerned with. Bitcoin is an underlying layer that facilitates that in this particular case. So Bridgeport allows you to define overlays, set the rules for those overlays, drop in valid things, and then also view the transaction in the most convenient way for the people involved with the specific interaction you're trying to make. And it does so in a way that you can easily verify. It's not a trusted service, really. These Bridgeport bridge nodes they're economic actors in the same way that the miners are. I mean, you've got to trust that the miners are going to act in their own economic interest. And so in the same vein, you have to trust the Bridgeport nodes are going to act in their economic interest to provide a cohesive and accurate representation of history and of the state. in the way that you've defined, or in the way that is defined by the particular bridge you're using. And so in the case of Convo Messenger, I would say certainly what happens is not directly peer-to-peer. The transaction is submitted to the Bridgeport bridge nodes that host a particular Convo bridge. And then those Bridgeport bridge nodes are going to respond in their economic interest, and notify any people who are listening for those particular transactions of the parsed versions of those transactions so that they're available to the recipients. So what happens is, you might expect on a Bitcoin native, where you're not doing anything above the layer of Bitcoin, where if I make a peer-to-peer exchange with you, I send you the transaction, and that transaction is received by you, and then you can validate it, and then you can provide me my service that I paid for. But in the case of sending a message, what I'm doing is I'm creating this transaction, I'm transforming it on top of Bitcoin in a very reliable and deterministic way, using a state machine, using a filter, using a transformer, and using a reader. And it comes out, and it gets notified to the recipients of those queries. So if I want to make sure, like for example, I have my Convo window open on my computer, and my Convo program is going to tell the Convo bridge and all of the Bridgeport nodes that I'm connected to, let me know if I get a new transaction from the person who I have pulled up. And that way, when that new transaction comes in, the Bridgeport nodes will all let me know about it. So it comes in from multiple places, because they're all acting in the same way, right? They're all deriving the same state in the same way from the same blockchain at the same time. So I get notified from multiple sources around the exact same time. And then that message is already parsed in the way that I need it to be parsed. I've already viewed that particular transaction, or the subset of that transaction. Maybe it's only a single output I'm concerned with. Maybe it's an op return or a token spend or whatever. And I get to know about the new event that has happened. And I also get to know about it from multiple sources and in the way that I need to know about it. So I don't have to deal with parsing and all of the protocol level stuff in an application on the client. I've already dealt with that, and I've already deterministically derived it, and it's economically incentivized. So that's why we have to have multiple. That's why we have to have, not just one single protocol for everything. I mean, people are going to create protocols on top, just like we can't do everything using only IP packets. I mean, you could define Zoom and the video conversation we're having in terms of IP packets. And you could say, well, first I sent that packet, and then I sent that next packet, and I sent the third one, right? And then you sent me one back. But that's perfectly fine. Mm-hmm. But the thing is that the layers of complexity kind of enable us to build on top. So instead of here's 3 IP packets, now we have here's the 3 IP packets that specifically opened up, what's a TCP connection, right? Now we're defining things in terms of data being sent over TCP, and then we build on top of that. So maybe then Bitcoin is built on TCP, or I don't know. I think it's actually might be TCP or UDP. I don't remember exactly which one, honestly. But point is, things layer. So when we need to define, yeah, go ahead.
Yeah, definitely. I think I understand your point. So the way I was, basically the way I was understanding was, like SPV is going to be that, not a second layer kind of thing, but it's more like a user network where it creates, mm-hmm. It allows the real P2P, transactions and so forth. So we can apply the same to messaging, or like other transfer of any data, and mm-hmm. all we do is using the Merkle proof, we can get the validation and even mm-hmm. broadcasting this data into onto on-chain. So when we talk about on-chain, like the transaction, right, you can yes, the transaction basically has UTXO, but you can also attach anything onto mm-hmm. that transaction, and with the unlimited block size and unlimited, once we get rid of the limit, you can basically attach anything on the transaction mm-hmm. Itself, and that remains on chain.
Mm-hmm. I would like to say you can ascribe any meaning to that transaction. You can view it in any, you can choose to view it in any way and to ascribe certain meaning to it. I think that's a more informative kind of approach, because yes, you can, from a technical perspective, place any chunks of data in any specific order or any opcode in any particular order. But what you're really doing, what we're doing as humans, is we are ascribing a particular meaning to a transaction or to a set of transactions. And when you write a protocol for that, and when you make that protocol fixed, the protocol itself, the meaning itself as ascribed to the particular set of transactions that you've created, becomes a commodity, which is interesting, because once it's there, once you say, this is what we choose to ascribe meaning to, these are the technical parameters by which we are choosing to express our ascription of meaning to a certain thing, then those parameters, once they become fixed and once nobody can change them, once there's no ambiguity, they become a commodity, just how Bitcoin, the protocol, as well as Bitcoin, the unit, like the Satoshis, they're both commodities in my, and maybe there's people that might beg to differ on that, but I believe that because the Bitcoin protocol itself is fixed, it has certain functions and uses, and I guess you can't own, well, maybe Craig is the only one that owns the protocol commodity itself, or the thing that represents it. But in some sense, I mean, I think there's some significance there, and there's some things that can be built based on that ascription of meaning to these transactions. And so with an unlimited, with a blank slate, so to speak, right? With an unlimited blank sheet of paper, you can write anything, and then you get to say, well, when I write this certain letter or this certain word or this certain sentence or this entire book of things, then that represents a certain thing. And but as humans, we have to choose to have it represent the thing that we define. Otherwise, we're just talking in ones and zeros, and that's what the Ethereum guys are doing, I think, and I think that's the wrong way to go about it.
Yep. So with Bridgeport, what you're really doing is you're adding one more overlay now, like a layer in between, or on top of Bitcoin, that basically that basically follows the same fundamental protocol of Bitcoin, but does to store. It
extends it.
Yeah, it kind of like extends it, and then but at the same time, instead of storing the Bitcoin transactions, it stores other forms of data.
Yes, and other forms of meaning that we've created. So what I've done is I've defined a framework by which people can create systems that ascribe meaning to events.
Got it.
And that's a very high level thing, but it's a framework that people can use to create systems that ascribe meaning to events. And so Bridgeport is a framework that allows, for example, the Convo system to ascribe meaning to the events which constitute Bitcoin transactions containing messages between users.
Yep, definitely. And in terms of the connection, or the validation of these messages, you're still you're not getting rid of the Bitcoin network, but you are, so all of these via the Merkle proofs, it goes. So when you look at some kind of Merkle proof, if I'm sending some messages via my SPV, wallet or SPV client, I can have that Merkle proof, and it
validates.
It validates on the Bridgeport, as well as it validates the UTXO, the fees that I pay on the Bitcoin network as well. So it does that seamlessly via the same Merkle proof. Am I understanding that correctly? Okay,
you are correct. And another thing I would say on top of that is I don't really like the word inclusion proof, because a Merkle proof does improve it. The Merkle proof does prove inclusion, but more importantly than that, it also proves order. Because with two Merkle proofs, we go back to block headers, and with knowledge of the chain of headers, not only can I say these two things happened, but I can also say A happened before B. And when I can say that A happened before B, nobody else can come along and say, no, you're crazy, B happened before A. And so when you do that, you have a cohesive order by which you can validate history. And you can say that when I have a Merkle proof for two events in the same block, or even in different blocks, you can get the order, and then you can deterministically sort of derive things from that order. Yep. And that's where Bridgeport allows you to be very creative, because you get to take the correct ordering of transactions in Bitcoin, and Bridgeport kind of validates that these orderings are correct before they send them through your processing steps, which you define as the creator of a bridge. Correct. And because that ordering is correct, your processing steps will always run in the same way, and you can be very creative about what you do. You could even write a counter that just counts how many Bitcoin transactions have existed since the beginning. And then, I don't know, every 10 transactions, you do a certain operation or something like that. And so the point is, you can derive and read. You can basically define a very deterministic method of reading history, and filter out the specific kinds of history that you want to read. And you can do some cool things there. So yeah, it's really just a framework for understanding history in a very deterministic way, and allowing people to, for the first time in human history, be very succinct about what it is they're reading, and everybody can kind of audit and verify and make sure, like, no, you don't get to lie and say that wasn't what it was, because here are the rules and here's how you broke them. And that's a mathematical proof. You provided the wrong transaction. You used the wrong ordering. So your view of history is mathematically incorrect. And that's not to say that we should build societies which are fully dependent on mathematical, analytical views of history. But in certain contexts, such as accounting, maybe governance and others, it can be a very powerful tool to create, I guess, good systems, or systems that are in line with what we think is valuable and, honest. I mean, the Bitcoin white paper uses the word honest quite a lot, and so it's a tool for auditing and making sure everybody's doing things in the right way. And it's an economic tool as well as a scientific one, but it is not a religion, and we can't think of it as, oh, well, just because we can build this code that determines the thing that should happen next, like that's what the future of society should be. That's not the way to view it, but it is a tool, and it can be used to create very honest systems that are incentivized in the proper ways, and that's the novelty there. That's the promise of what can be built with it, and that's something that happens on top of Bitcoin. So without Bitcoin, we wouldn't have the time chain. We wouldn't have the honesty as a service part of it.
Yep. So when I look at Bridgeport, so it'll have to follow the exact same principles of Bitcoin, just as an overlay network, like an overlay network, just like an extension. So when it comes to incentivizing, somebody running a node, and storing this, say for Convo messages, all the messages, and or even hash or whatever, it has to follow the exact same principles of Bitcoin. Do you see down the line that because of course we're not expecting any protocol change on the Bitcoin layer, but any more additions, any more change to Bitcoin fundamental itself that you might have to update in the Bridgeport? Why not? What's the advantage of having that overlaid network in between the SPV and the Bitcoin on-chain network? Is it just to get rid of the overhead that miners have to go through if they have to build this infrastructure? Just if we build more and more apps, and every time
you'd be putting a lot of load on the miners at that point.
A lot of load on the miners. Then we can have problems. Is that the sole sole reason to building this, or is that what's the drive for
Bridgeport?
Yeah,
Bridgeport is really just a way of looking at Bitcoin. It's a way of viewing. So Bitcoin is really the underlying, of course, it's the single source of truth, so to speak, in the sense of providing the ordering of what happened. So tools like Bridgeport, or frameworks for creating systems, like I said, that's what Bridgeport is. It's a framework for creating systems. These sorts of things are all just ways of looking at Bitcoin. So we have this history, we have this thing, and now you can say Bitcoin means this happened.
Yep.
But Bridgeport answers the question, well, so what? So what this happened. So now, so what, we're going to order these transactions in this particular way when viewing it through this particular lens. So we're going to have a bridge that can track certain things and can define sequences of events and sequences of interactions between people. And it can enable all of these sorts of things. It's just a way of viewing and of ascribing meaning to the things that are already there in Bitcoin. Because up until now, people have just said, well, we have this thing and it's on Bitcoin. And there it is. But they haven't actually looked at it. They haven't actually gone and parsed the transactions and found the correct ordering, and then derived meaning from that ordering and created a layer on top to actually, they haven't created a framework for looking into it and actually seeing what's there and what can we, there's different views of history. There's different bridges in Bridgeport, but not only are there different bridges in Bridgeport, there's different Bridgeports that can happen. There's different ways of creating systems on Bitcoin that view the correct ordering of Bitcoin. So just because somebody creates a Bridgeport bridge does not mean that's the only way to even arrive at a particular set of circumstances or a particular state for a particular protocol. You could have a Bridgeport bridge that runs Convo Messenger, and then you could send an email over to Tal or Mempool or something and ask them to track the transactions and look at them in a similar way, right? And aggregate them in a different way. And so the point there is Bridgeport is just one way of looking at it. And I think it's the first way to view Bitcoin and ascribe meaning to the things that have happened on Bitcoin. But Bitcoin is really the ledger. It is the source of all of these things. And so when all these interactions are on chain, the cool thing is that 20, 50 years down the line, somebody can come along in the future and say, we're going to take all that stuff that happened in 2021 and we're going to parse it and we're going to view it in a new light. We're going to give different meaning to the things that happened in the past. But the power of Bitcoin, not Bridgeport, but the power of Bitcoin is we can always go back. And as long as somebody thought it was significant enough to keep around, there's always going to be proof. The chain of headers, and that was the correct order. And that was a thing that happened in history. And when you have that connection there to the chain, you can view things in new lights. You can reinterpret that same information. You can reascribe new meaning and learn new lessons from the mistakes that people have made in the past in history. And that's something that Bitcoin does. And Bridgeport it's the first time that somebody has stood up and said, hey, wait a second. We can actually use this to ascribe meaning to things. We can actually be very deterministic about these specific Bitcoin transactions mean that two people were talking to each other on an application called Convo Messenger, for example. That's our basic, for those who don't know, Convo Messenger is an on-chain messaging app that allows you to communicate privately with two people. It's very simple on-chain. So every message gets encrypted using keys that only the two people involved in the conversation have, and that message goes on-chain, or there's a hash of the message that goes on-chain. But either way, that's kind of how it works.
Yeah, got it. Yeah, so this is so the Convo messaging, it basically so. And the reasons I'm asking this question is, I think we've had several conversations on this as well. When we're talking about an operating system, we're talking about like a phone,
Right.
Built on Bitcoin. So all these applications that we're talking about is ultimately going to be useful, in that vision, right? So because when I think about a phone or watch, You know, and I think of it as an SPV client on Bitcoin. So if you know, and it'll have all these hardwares that allows two phones to start connecting, I mean communicating with each other, and we can build anything on top of it. You know, you can build music, you know, music, you know,
music
transacting,
streaming
yeah, music,
services and
videos, phones, photos, social media, and all these, and like even like convo messaging, right? So
right.
I can start sending message to you
That's
using these.
basically SMS. Yeah.
Yeah, so yeah, basically I can start sending messages to you, but then it'll be a proper P2P, but at the same time we can have this third ledger, which is going to be the Bitcoin ledger, where we can decide whether we want to publish that the whole message as an open text, or do we want to do a hash. That's something that we can,
Encrypt it.
yeah, encrypt it and so forth. But and it's going to be that Bitcoin ledger is going to be that that ledger which allows us to down the line in the future say, okay, what really happened,
Right.
and you know the advantage of having that ledger, maybe an open text, is just to figure out exactly what messaging was sent between each other, but at the same time we could even hash and then have give power more to the users for privacy and so forth. So
right.
So yeah, a lot of these things. So I'm still trying to wrap my head around in this you know framework, like where does the Bridgeport really stands? Is it going to be on the SPV client? Is it going to be on the Bitcoin side? Because this is an overlay. Where does it really sit? You know, that's something that I'm really having hard time like understanding it. So
right.
yeah. So do you,
what we've got here with Bridgeport is all these things you described: a social networking app, a video streaming service, a music streaming service, dare I say, an entire abstract on-chain file system that could run, as you say, an on-chain operating system for a single device. That you know, a user has a single abstract device that can manifest itself onto one or many of a user's physical devices, and then move running apps between devices without having any problems. All of those are just ways of viewing particular Bitcoin transactions and ways of creating particular Bitcoin transactions.
Absolutely.
And so when I create a new file in this abstract on-chain file system, that can be a Bitcoin transaction that is created using a certain set of, you know, defined standards and formats for certain parts of that transaction. You know, you put the outputs in a certain way, you put certain data in certain places. And so Bridgeport is really just a way of setting that up, setting all of that up, you know, saying, well, when we have this Bitcoin transaction that was created in this particular way, then here's what we need to do in order to arrive at a file system with folders and subfolders and files and thumbnails and created ad and updated ad and all of those things that are file system specific. That if you were in Bitcoin, you'd have to look at, okay, well, the 7th push data element on the stack at this certain point in script evaluation would be the created at, you know, label for a particular file. And that can only change at creation. It can never change after the file's been created, because that's the created at label. But the updated at one can. So coding all of those rules, I mean, you can do it in terms of Bitcoin, but if you create a deterministic reader that takes these Bitcoin transactions and parses them into the correct format, and then enforces the rules in order to define constraints by which these new databases can be updated, then what you do is you arrive at a better way of more efficiently tracking this information. And if the methods by which this information can be parsed and tracked and updated in the database, and the rules that define how it can be updated, the code that defines how it can be updated, is made public, if that information is available and anybody can pull down that same information and run and arrive at the same set of results. And so what it does is it takes away the authority of central servers that would otherwise do that. So if you wanted to do that client side without Bridgeport, what you'd have to do is be aware of all Bitcoin transactions and then make sure you have the right ones. And when you want to check something, you'd have to run all of the state of the entire protocol through, and in order to arrive at the state that you want, so that you can know whether your update is going to work in your particular file, right?
Yep.
And so what Bridgeport does is it delegates that service so that the client, the SPV client, doesn't have to do all of that work and all of that processing. Instead, it's paying a Bridgeport node to do that for it. And it's also multiple Bridgeport nodes, so that not one node can just lie and say, well, here's the state, and I promise that's what it is. Because as a client, I can ask 5 Bridgeport nodes who are doing the same exact task and competing with one another. And when I get a response and 4 of them say one thing, and the 5th one says a second thing, and they're all signed, the Bridgeport node operator has sort of signed off saying, well, this is what I attest to be the correct thing, and here's the current timestamp and the current block hash. I know that one was lying. And I can make that public for the world, and nobody's going to, they're going to say, okay, what's going on here? Why is this guy not telling the truth? What was the issue that he made? Is he correcting it? And really it's a human reputation that is ascribed to these entities, just like how the Bitcoin miners, if a miner is consistently mining double spends, you're going to think, well, I'm probably not very happy with this miner, and they better stop it, or else I'm going to start orphaning their blocks. Or in my case, if I'm an SPV user talking to a Bridgeport node, well, this guy better stop it, or else I'm never going to ask him anything ever again, because he's a liar. And when I stop asking, I stop paying. And when I stop paying, the Bridgeport node who responds to my queries doesn't make any money. So it's an economic game. And so where Bridgeport sits, to answer the original question, is users talk to Bridgeport nodes, just like how users in Bitcoin talk to miners to broadcast their transactions. And they read the data, the state from chain, including, you can incorporate Merkle proofs into the responses that Bridgeport nodes provide for particular queries in your protocol. So the Bridgeport nodes can give the users SPV proofs for all of the transactions that have created the current state that they're interested in. And that way the users can validate it themselves, or they can trust, it depends on how you design your bridge reader, your bridge transformer, the things that take the Bitcoin transactions, parse them, and put them in the database. Because given an incoming Bitcoin transaction, at the top, you have the Merkle proof, and you can store that in the database if you want, or you can choose to drop it, right? But the point is, it's there, and people can decide whether it's valuable. That information is validated client side as well. I think they probably will, but I haven't done that yet, but it is possible. And so Bridgeport nodes sit on the Bitcoin network. They have a very strong interest to, number one, synchronize with one another when they're running the same bridge, because they want to make sure they all got the same transactions. If I get a new transaction and I don't share it with everyone else, it's not in my interest that I'm out of sync. So I'm going to let everybody know about this new transaction I learned about, and they're going to let me know too. And it's in my interest to know about every transaction that anybody wants to share with me, because I want to make sure that what they have, I'm in sync with. So they'll stay coordinated. They'll make sure that the ordering is happening correctly. They have very strong economic reasons to do so. And so they sit on top of Bitcoin. Users talk to them, and also miners talk to them, because when I learn about a new transaction, the miners need to let me know what the Merkle proof is, so that once it gets included in a block, I know the order where that transaction needs to be with regard to the other transactions. A came before B, B came before C. And so if I have B and C mixed up in the block, because I get 2 Merkle proofs, I'm going to make sure I roll back and flip those 2 around to make sure I get it right. And so all of those things are worthy of consideration. But the point is, users talk to the Bridgeport nodes. They kind of, they sit in between the users and the miners. So if you've seen the Mandela network diagram that Craig Wright talked about in the theory of Bitcoin, he drew on his board. He got the very closely connected things in the center. Those are the miners. And then you had the middle, and then you had the outsides. There were 3 layers. The users are the outside. The middle is the overlay network operators, and the center is the miners. So users would rarely talk to miners directly. they would talk to Bridgeport, and Bridgeport would broadcast these new transactions to all the Bridgeport nodes that are concerned about them, as well as to the miners. And so using this Mandela structure, the miners are aware about the Bitcoin layer, but the miners, and they're aware about getting Merkle proofs out to people that need them, but they're not really needing to be aware about every single, every single kind of, every single specific thing about every single protocol that's happening, because we want to have an ability for people to specialize, and that's what Bridgeport kind of provides, is a framework by which we can define different things in different ways, and different Bridgeport nodes run by different people can host different kinds of bridges. Like maybe I really don't like, I don't know, Java or .NET or some horrible language like Objective-C. So if someone's going to write their Bridgeport bridge in Objective-C, they can go and write a letter to the ghost of Steve Jobs and ask that he host it, because he's the only one in the entire world that cares.
Yep.
But in my particular case, the point is specialization will happen, and competition will happen, and the market kind of provides these things. So that's kind of how it works, and that's how applications work in that way. So you are building an SPV application by building a messaging app or by building a video streaming service, but beyond that, you're also building a messaging app or a video streaming service. And so you may not necessarily care, as long as it is there and it's been validated, that about all the Merkle proofs and all that underlying stuff that's not really Bitcoin specific. It's not really specific to your own thing. It's specific to Bitcoin, and that's just an underlying layer. So you might be worried about making a Bridgeport bridge for your thing and defining your protocol and setting things up in the way that you want them to be set up for your particular use case, more so than, as a web developer, I'm not worried about SYN or ICMP or any of these other things that are on the lower level things that, are light reduction for fiber optic, I don't even know what I'm saying.
Yeah.
So the point is like,
so I think I understand.
Underlying
so
layers.
Just to summarize, so there's this core network in the middle, highly connected.
Those are the Bitcoin miners.
The Bitcoin miners that basically validate the transactions. It's very raw in terms of just validates the UTXO and transactions, and
get it in the right order, get it in the block, get the Merkle proof out, and get the block header and propagate your block to the next miner. Do the things that miners do, right?
Yep. And then there's the in between layers, which could be a video streaming network, or
just different
like
ways
Bridgeport.
of viewing those lower layers.
Exactly, and it could be any sorts of like file systems, and then which sits in between the SPV users, and SPV users are the ones that really creates an economy, in terms of trading whatever data, messages,
they interact with the
money.
protocols that have been defined on the lower layers.
Exactly. So I think it all makes sense, because instead of having this all in one versus the other, it's better to have more like Mandela, like you're mentioning Mandela, network of all these inner, just like how you see in a tree. If you cut the tree, you see all these rings. So it's better to have all these rings of specialized layers in between, which all still follow the Bitcoin protocol. And all it does is it collects these transactions from the users that basically start create the users that creates transaction, and just passes on to the main core, the core miners, in terms of some kind of transaction or hashes or whatever it may be, and creates this whole network. Okay, it all makes sense. I think that really also probably aligns with the vision of going back to the restaurant thing, right? So if I go to a restaurant and I leave my phone there, I'm not going to lose all of my data, because I was thinking from along those lines, where if I create an SPV, if I have an SPV watch or SPV device, and I store at least all of my data there, and just send some hash over to the Bitcoin network without all these overlays, might work. But
you're one of 1 trillion transactions. Good luck finding the one that you made.
Yeah.
You know what I mean?
So it doesn't.
But you need a way of tracking it.
Yeah, it doesn't really allow me to because with this overlay networks, it kind of distributes all these data over to these
Right.
in between nodes. So all I need
allows it to specialize.
Yeah, and that's why, because it's distributed in such a beautiful way, that even if I lose my phone, I'm not losing all my data.
Because you have some state machine out there somewhere that's set up to track your particular data, and you can come back to that. You know, you can use the I don't know, device, the abstract device manifestation protocol, ADMP. That is the protocol by which the abstract on-chain version of your device can manifest itself into a new physical device. So if I have my computer and I have my phone, they're both running the same kernel, the same operating system at the same time. They're both making use of the same file system and executing the same programs, and basically in parity and mirroring. And one process can be running on one device and it can be handed over to a new device. And the point is, like, all of that is tracked on chain as it happens. You're no longer having each device with a separate kind of state that is just specific to the physical hardware. Now it can be part of the global time chain. And when you want to pull it back down onto a new device or whatever, it's there. And when everything is standardized, imagine when we have a standard protocol for loading things into RAM on the virtual on-chain device, and then I don't know, executing sets of instructions using the virtual CPU, and then sending out things to the virtual screen. All of those things are going to take a very long time to build, but in 20 or 30 years, I mean, that's what I think is going to happen, is these devices are going to work in such a way that, oh no, I left my phone, like you say, on the table at a restaurant, and I picked up your phone and you picked up my phone. And it doesn't matter, because all these physical devices are programmed to be is windows into the abstract on-chain device. They're just like dummy terminals, like you had in the 1960s when you had the one mainframe, and then all the it's funny how it comes back to that. You have the one computer, and then you have all these dummy terminals, and it doesn't matter which terminal you walk up to if you're at Stanford or whatever, because your single user account is going to log you into your installation. Your thing is set up the way you want, no matter which computer you log in on. And so that's how it's going to work. And so maybe I had a nice case on my phone, or a nice sticker on the back, and maybe I don't have that anymore. But when that phone is programmed to scan my face and run it through and pull down my thing, and your phone, or when both of the devices are programmed to do that, it doesn't matter which device I pick up physically, because my stuff's going to be there. I'm the one that's logged in. It's my identity, and there's really no losing your identity. Like if somebody breaks in and acts as you, like that's a big deal. We got to call the Stanford system administrator and say, hey, somebody got my password, so we need to get that reset. And that's kind of how I see this happening, is yes, there's different paradigms for security. No longer it's a crunchy shell. Everybody has a single identity. There's no service that just manages identity, like how Google, you log in with Google everywhere. So Google is the service that someone gets into your Google, they get into to everything. But the point is that Google is managing an identity for everybody. Everybody has a Google account, right? And if somebody breaks into Google, then they can use that authorization that they gain to, hack into hundreds or thousands of different services and compromise every user of every one of those services. And that's where we have distribution of identity to all of the different users, and it works out in a different way. I'm not going to say it's a better way, because in 50 years somebody's going to come along and say, no, you got to do this a different way, because there's problems with this. But that's my answer to the whole advertising model, where nobody owns their identity and there's no incentive. So for like privacy and things, I think that's what Bitcoin tries to. I think Bitcoin is a great tool that humans can use to solve those kinds of problems. And Bridgeport is one of the pieces that makes that happen.
Yeah, definitely. And I think like in these, and it's also another problem as well, where it comes to like, yeah, I own my data, because in all these overlay networks, yeah, say for example, there's an overlay network that basically stores all like people's biometrics, right? But it's you who really give the meaning to that biometric. It could be it's just a bunch of biometrics.
All they're doing is reading your data from the chain and ascribing a certain meaning to it.
Yeah.
And it's on chain already. It's not like they can go and change it. If they build an overlay network that defines something in a certain way, that overlay network is only one way of viewing Bitcoin. Even if all of Bridgeport was all overlay networks built on top of Bridgeport were somehow, I don't know, just bad. Somebody just decided arbitrarily, like, everything on Bridgeport is bad. Well, guess what? Bridgeport is only one way of viewing Bitcoin. And people can view Bitcoin in any way they would like. And it's about what the most people are going to ascribe the most meaning to. What protocols make the most sense? What is the best way to view Bitcoin? And in order that we can use it as a tool most effectively to solve whatever it is we're trying to solve, whatever problems we think we're trying to solve. I mean, it's a tool, and we can use it for that. We can view things. We can choose to find a meaning. That's almost a philosophical viewpoint, right? But it's like the whole thing is the reason why my life is meaningful is because I choose to find meaning in certain things. And so Bridgeport is a way for people to choose to find certain meaning from certain aspects of Bitcoin and from the certain transactions that have been made in certain order and everything else like that. It's really just a way to make sense of the history, or it's a framework for defining systems that make sense of the history that has been stored in Bitcoin. And that's really only possible. And I said this before, but it's really only possible with on-chain scaling.
Yeah.
You can't derive state from data that isn't on chain because, well, that data doesn't exist in the framework of what you can derive state from. Maybe you can put like the Merkle roots to some things on chain, but I mean, everybody has to keep around what they want to keep around, and I think that the best way to enable that to happen is to allow people to put things on chain when they want to have them put on chain, and to use the ledger the way that a ledger was meant to be used. And so that's the benefit I see in kind of doing things this way. And I think the cost for putting something on chain, the cost for inclusion, should be as low as possible, so that as many people and as many actions and as many events as possible can be included in our global recording of history. And it's not that one person is going to do that recording, it's that the people who find the most value in particular things are going to do the recordings that they think are that make the most sense and that they get the most meaning out of. Yep. So that's what
Definitely.
I think is valuable there.
Definitely. And I think now it all makes sense to have as many overlay networks in between the central core versus in between the users versus the core, because I think that's where the privacy probably comes into the picture. Because like, say for example, my device has an ability to capture the biometrics data, but then with the biometrics, it just doesn't unlock me fully. It only unlocks the biometric overlay network.
You can do a threshold, or something like that.
Exactly, and then
a password and biometric.
Yeah,
or
and probably the more networks in between, say for example voice or my photo, all these networks in between, then and if I travel from from the SPV to the core, that's when I
Mm.
basically unlock my identity, right? The full identity. So I think that makes so much sense now. And I think what you're doing with Bridgeport does help that as well. All right, makes so much sense. Yes. So what's your future like? Where are you with your future, like the vision? Where are you right now with with what you're trying to build? Especially like thinking from those lenses of going to a restaurant and just picking up any phone and be able to do, be able to walk out with any phone and still be able to carry all your data.
Right, you wouldn't
With
even
that vision,
notice.
how far are you with that?
Well, what I want to do is, Bridgeport is all about reading. Like I've said, Bridgeport is a lens into Bitcoin. It's about reading from Bitcoin.
Yep.
And there's many things that are built on top of Bridgeport, as I've just already talked about. I mean, we have Nano Store for storing content and making contracts about how long something is going to be hosted by who and everything like that, right?
Yep.
But that's just something on top of Bridgeport. There's other things that are necessary. Bridgeport is very useful, but it is not the entire picture. It is not even most of Project Babbage, because Project Babbage needs to provide Bridgeport for reading from applications. But as an application developer, not only do I want to be able to see what is in my application, not only do I need to be able to know what the state is, I also need to be able to create updates to that state. So my users need to be able to, encrypt things with keys that only the user has. My users need to be able to create Bitcoin transactions that mutate the state of Bridgeport state machines, or Bridgeport bridges, I should say, sorry. They need to be able to create signatures and have certificates that attest to their identity and its validity. And those certificates need to be tracked probably inside Bridgeport state machines because they're on chain. And anything that's on chain can be tracked using a Bridgeport bridge. But the point is, Bridgeport is the way of kind of building APIs on Bitcoin. And the way that you interact with those APIs is by creating Bitcoin transactions that mutate the bridge that you're trying to mutate, or that update the bridge you're trying to update. To create new records, or that give instructions like that a record be deleted and all of that stuff. But as a user, I need to own Bitcoin. I need to have Bitcoins that, yes, I need to own Bitcoins that I can use to create Bitcoin transactions that make these updates. I need to have sets of keys, as I've said, that allow access to my data, that encrypt, that sign, that allow me to have an identity that I alone control, that allow me to log into myself. And that self can be the thing that acts across applications and takes actions on behalf of the user and all of that stuff. So Bridgeport is in a state where people can use it. You can go on bridgeport.babbage.systems or whatever, projectbabbage.com/Bridgeport. And you can go and watch my video and read the documentation. And I hope you like JavaScript, but you can use JavaScript to create a Bridgeport bridge, and I'll run it on my Bridgeport node. Or you can go through the trouble of setting up your own Bridgeport node and run it however you want. And you can write your Objective-C Bridgeport bridge. But that part is actually fairly well completed. And there's some things I've built on top of it, including I created a Bridgeport bridge for user management, created a Bridgeport bridge for checking what is going to be the the hash of a file and a user that's kind of made a commitment to host a certain file, and all of those things. But the users need to have user accounts. They need to have keys. They need to have hierarchies of keys. There needs to be tracking and permissioning to ensure that certain apps have authorization to perform the actions they're performing on behalf of users. There needs to be a file system accessible to all apps. So I need to have a Bridgeport bridge that creates a protocol that defines a file system, and having users be able to own files, share, collaborate, multi-sig for creating updates to certain things. I mean, imagine a file that can only be updated when 2 out of the 3 maintainers sign off on the update. Well, that's kind of like an on-chain GitHub, where you have the master branch folder, and everything inside that folder is in the master branch, so to speak, of a repository. And you can only update that and merge new things in with authorization from the various parties who are involved. So all of these can be viewed in the lens of being a Bridgeport bridge. But what I need to do is allow my users to be able to use more current and conventional platforms. So until we have this abstract operating system and an entire set of apps and a home screen and a notification center and an app switcher and all of those things built out on desktop and mobile, and until I start shipping custom hardware that runs in this way and that can communicate over a peer-to-peer mesh network, and all of those things, what we really need to do is enable support for all of the existing platforms. So things like iPhone, right now, you can run Babbage apps. If you go to convo.babbage.systems, you can run that on your desktop computer. You have to download the Babbage desktop software, which is
I'm actually doing that right now.
Okay.
Yeah, I'm actually doing that right now. So I just put I just put my phone number and got a code. I'm setting up a password. So I'm creating an account. So walk me through this. Like, what is it really doing while I'm doing it? So
that account is your Babbage account, and you'll be able to use that single account across all of the different Babbage apps. That password that you're creating right now, it's going to pop up on the screen and say, what's your password? Like across all the different apps you're using. So that's going to be like your password across everything on the whole MetaNet. And what it's doing is it's using a thing called the user management protocol bridge on Bridgeport to create a new user account defined in terms of an on-chain Bitcoin transaction associated with your identity. And that is your identity containing all of your keys, your authentication factors. It's not publishing your phone number on chain, but it is publishing a key that can be associated with a server, so that when you prove ownership over that phone number, then my server will kind of give you that key, so you can use it to find all of these different aspects of your identity just by having your phone number, as long as my server stays on. But the idea is that now there's a record on chain of your identity, and you exist as a on-chain person who can interact with all of these different applications, who can sign things and encrypt and decrypt and all of that stuff. And so what I was saying is, right now you can go to convo.babbage.systems and you can set up a Babbage desktop, and you can interact with all the different Babbage apps on your desktop computer, Windows, Mac OS, or Linux. But I don't have support for iOS or Android yet. People can't build a Babbage app that runs on the MetaNet that works in this particular way, that works on iOS or Android, just because I haven't built that yet. I've only built the stuff for desktop. So that's something I want to do in the future to kind of.
So I just it popped up a Babbage Explorer. So it also asked me for a paymail. So that so all of these. So whenever I create a paymail, it's actually creating a transaction on chain. Is that right, or is that what creates a?
So what happens is I have a paymail server that runs as an internet website on the internet, not the MetaNet.
Oh, okay.
But when you create that paymail, it's associated with a key that only you have. And so my server is going to identify you with your particular paymail key, and only you can create signatures from that key. So only you can manage that paymail. But the transactions that come into your paymail, we're using, XPub keys, they're called, or public derivations, so that only you have the private keys associated with the money that is coming into your paymail if somebody tries to pay you using your paymail. And that profile photo and the name and everything like that you're setting up when you create a new account on Babbage Desktop is stored on that paymail server, which I run. Now, eventually that will run as a Bridgeport bridge, hopefully. But we need to have on-chain, we need to have an on-chain sort of method by which we can define stateful interactions between servers and clients on top of Bridgeport, which sounds crazy. But once that's implemented, then we'll be able to do all of that stuff completely on-chain. Eventually there's going to be hopefully on-chain phone numbers. So the whole secret server with SMS and all that can get out of there. But, it's going to be a little while. So the point is, we're using legacy technologies as little as possible until we can facilitate the transmission, the transition to the new technologies. And we are defining that transition in the best way, by trying to reduce the trust involved with those as much as possible, such as, the pay mail, it doesn't store any private keys, only you have the private keys. And with your phone number, it's not putting it on chain, it's just public, it's keeping a key associated with that phone number. And then when you enter the correct code, it gives you that key. So you can decrypt the next step, right? Then you can enter your password and go from there. So
yep. Got it. So one more like one question. So all these so for example, ultimately, like all these apps are gonna be is going to be transcribed to like on-chain data. So
every
for
action
example,
you take is
yeah,
on-chain.
so because from with the vision with Bitcoin, Satoshi vision, like if I carry my data wherever I go. So for example, tomorrow, I wanna take my data out of Convo Messenger, and then I wanna view it in a different app, which is say Convo, safe. Just
Convo Dark is one that exists.
Convo Dark. So or something way different, like a different app. Would I be able to still do that because we have maintained the standards, or is it going to be like app specifics?
Well,
so
every app can look at Bitcoin in any way it wants, but if I know that Convo stored certain data in a certain way, then what I can do in terms of my app is, if I want to extend Convo, I can write a Bridgeport bridge that takes all of Convo. It takes a superset of Convo. It takes all the Convo stuff, because I know how that's stored on chain.
Yep.
And then it also allows extensions, so other things.
Got it. Okay.
If I wanted to add video support, which Convo doesn't have at the moment, I could write a Bridgeport bridge that takes a superset. So every Convo transaction and every transaction that uses another protocol that's specific to video. And then when I want, as the Convo video, Convo with video support application, I could query from my Bridgeport bridge, which includes the Convo Bridgeport bridge's content, but it just views it in a different way. So if they use the same standard, then great, use the same bridge, because there's no point in defining two bridges that view exactly the same thing in exactly the same way. You may as well just use the existing one. But if you want to extend, you can just create a new Bridgeport bridge, set everything up the way you want it to be set up, the way you think it should be set up, view Bitcoin in the way that you want to view Bitcoin, and create the app the way you want to create it. Now, you mentioned take my data out of Convo and put it into a new app. I think a better way of putting that is the data was never in Convo. Convo just viewed, it views the data. So Convo Dark gets to view that data how it wants to view it. But at the end of the day, Convo Dark has to ask you, and it can only, so your data is encrypted, right? So if Convo encrypts the data with the 2000th key in your key ring, right? Then Convo Dark has to also ask you, because Convo Dark should know, like, this data came from Convo, so it's going to be encrypted with the 2000th key in his key ring. It'll ask for the same permission so that it can decrypt that data and show it on the screen. So I can use the decrypt function to kind of unlock it. But the 2000th key in the key ring, as well as the data itself, will never leave the client device. So the data itself is represented in the UI without ever, the Bridgeport bridges don't have to know about the actual content of the encrypted data, even though they know how it is encrypted. I know that every user has a key number 2000 in their key ring. And that key number 2000 is specific to this type of data in this particular context, being encrypted in this particular way. And then that user gets to say which apps, which websites they're visiting, get to decrypt what and with what data. And that's permission management. That's another thing I have to build, and I have built that. It works. All of the permissions are managed on chain using Bridgeport bridges that manage which apps get to encrypt and decrypt, and how much money each app gets to spend. All of that's tracked using on-chain protocols. If you go to bridgeport.babbage.systems, you can scroll down and you can read the DNS-based path access control protocol, or the DNS-based spending authorization protocol. And you can see exactly how that data is checked on chain. And so if you go to all of these different sites and everything, you can see how I've defined my protocols for how my users work. But an interesting thing is that because users are tracked on chain, like if somebody creates a competing version of Babbage Desktop itself, or maybe they create a mobile version before I do, the point is the users can still log in. Even though I created them with Babbage Desktop, the users are the ones with that password. The users are the ones with that phone number, with that key and everything. And so the point is, like, the user owns their identity. They don't have to use Babbage Desktop. They don't even have to use Project Babbage. This is MetaNet. It's not BabbageNet. I didn't call it BabbageNet because I don't own, I'm not the one who runs this. I just set up some convenient ways of looking at Bitcoin. And I think those ways are going to be beneficial. But if people can think of better ways of looking at Bitcoin, then that's kind of where I'm going, is how can I best look at Bitcoin to serve people? So that's my long-term view, is
so it's
I just
more
have to
like
build all this stuff out.
it's more like the way we view it. And also you mentioned like sometimes earlier, like it also might be able to collect the transaction. Does it any like, so for any apps, these apps collect. So for example, I'm looking at Nano Store UI, and it says file to host. So if I upload a file here, it stays in the Babbage Bridgeport, or does it is this file hosted in on chain?
So Nano Store is a different service that runs on top. But if we're viewing this, I mean, why don't we use like Convo Dark versus Convo as the two apps? Because Nano Store introduces another layer of complexity that isn't really relevant to the core design. It's just a way of storing data, but Nano Store has different incentives. So if you're looking at, I don't know, if you look at Convo Dark, right? It's an app that exists. And kind of once we cover that stuff, then it'll be easier to understand Nano Store in the future. But these two apps that exist, if you send a message to me using Convo Dark, number one, I can receive that message using Convo Lite. So I don't even have to use the same app as you do, because my app is viewing the state of the Bitcoin blockchain, and your app is writing to the state of the Bitcoin blockchain. And so we don't even have to use the same app to communicate. But in fact, I've never actually done that live. I've never actually done a cross-app communication. I know it works.
Actually, I just sent you a message from my Convo Dark to you. So I don't know.
Okay, let me pull up Convo. Let me pull up Convo Lite. Just Convo normal. Convo.babbage.systems, and I'm pulling it up here. So let's go to Babbage Desktop, and I'll open it. Here, hang on, Babbage Desktop. So I'm launching my Babbage Desktop. Here it is, and it's pulling it down. So syncing all these state machines. Yes, you said hi, Ty. So I will come here and I will send another message. Hello from the light side. And I'll send that off. So it's going to ask me if I want to take the action. And there it went.
Oh yeah, I see it. I see the hello.
So it did update live.
Yeah, this is on my Convo Dark. So yeah, this is exactly what I'm talking about. Interoperability.
For the first time in history, this is significant. For the first time in history, we just made a cross-app interaction. That's never happened before.
That's good.
I knew it worked in theory, but I've never tested that until now. So that's very cool.
So walk me through, how are you really doing this? So these are two different apps, but
they're using the same Bridgeport bridge in the backend.
Okay, got it. Okay.
So the Bridgeport bridge parses the message transactions. There's a standard message, so you can go on bridgeport.babbage.systems, and you can go and look at the Convo user messages protocol bridge and see the manner in which the data is encrypted, the format it's stored in the bridge, and you can even look on GitHub for the source code. And so both of them use that same underlying protocol. One of them just happens to be in dark mode. I wrote some extra CSS. And the other thing is Convo Dark is actually cheaper to use than Convo. So if you use Convo Dark to send your messages, you're paying the developers less money than you would be to use Convo Lite. So people are probably going to use Convo Dark because they like dark mode and because they like to spend less money. So those two apps are competing not only on UX, but also on price. Maybe if I wanted to pay a little bit more to have better animations, somebody could build a version of Convo that runs in that way, and they could actually make money from that. And the point is, like, if I create this front end, I don't own the data associated with it, but I can still create. For the first time, I can write code that represents a user's messages without having to write the code that originally created those messages. And that's the point of Bitcoin and of Bridgeport, I should say, which is to be able to go back and reinterpret things in a better user experience, or in a better light, or in a more, maybe not better light, but in a more correct light, or a more optimized light. So there's messages that maybe I sent 10 years ago, and somebody creates a new version of Skype, and this Skype has better animations, better user experience for many reasons, because Skype could have better user experience for many reasons. But I still have those in this. Now I have this better way of viewing everything, but I still have access to all that old data. Yep. That's the vision here. It knows who I am. And if I go to Convo Dark and I send a secret message, it'll ask for the password, because I have one password across all my apps, and I need to use that password to encrypt the data, right? So I use that password to unlock a key that is used to then encrypt that message in a secret message. And then if I receive that message in Convo Lite, I'll be able to use my password to decrypt it. And if you send a message in Convo Lite after you sent one in Convo Dark and it asks for a password, well, you only have one password across all your different apps. It is your one MetaNet, the password associated with your identity on the MetaNet. So it knows who you are. And if you pull up Convo Lite and Convo Dark in two different tabs and refresh the page, they will stay synced up. You'll see that message that you sent me. So if you go to Convo Lite, just convo.babbage.systems, it's there. It stayed in sync. And that's because it's viewing the data from the same blockchain, and that's how Bridgeport works, and that's how these two apps communicate.
Got it. So it's more like, so all these middle, like Bridgeport, is just a way to view data on a blockchain in a specific way. So for example, it's gonna, if I look at this transaction on a blockchain, I look at some kind of transaction ID or whatever, and with couple of code, I know that, oh, this is coming from Convo Dark or Convo Lite, and I can also view the same way back and forth. Is that what I'm understanding?
Well, you create transactions that are formatted in certain ways, and then I don't necessarily, when I'm writing the Bridgeport bridge that processes the incoming transactions, I don't care which app created the transaction. I care that it's formatted properly so that I can do my processing on it, and so that I can put it into the bridge in the correct way. And then I can pull it out and I can listen. I have live events that work. I can send a live, event for anything. Like I could say, when the smoke detector emits the 10th transaction in 10 seconds where the sensor's been tripped. After that 10th transaction, send a live event out from the Bridgeport bridge to a webhook or something, not necessarily to a webhook, but to a listening, to somebody who's listening at the fire station, who will then sound an alarm and provide the address and all that stuff. And the point is, like, all of that runs deterministically. So every Bridgeport node who is being honest will emit that event to that listener if that listener is listening. So as a Convo Dark user, your Convo Dark went to the Convo user messages protocol bridge, and it said, hey, let me know when the person named Shamir sent a message or received a message. And then if Bridgeport.babbage.systems is a Bridgeport node that is honestly hosting that bridge, and also if, I don't know, Bridgeport failover.babbage.systems, a second node, is also honestly hosting, both of those nodes should send you alerts. So you're gonna know, if you're listening to 20 nodes, you can listen to as many nodes as you want until you're convinced you have the correct information. Just like with the miners, you can query for block headers until you're convinced you have the longest chain. It's the same concept. It should be everybody who's honest knows what the correct thing is. And so you can talk between things, and you can have events that get triggered that cause certain things to happen.
So what I'm trying to say is, like, when I look at the Bitcoin block, the blockchain itself, the messages that were just exchanged, and it creates some kind of like a transaction, and it's gonna be like basically zeros and ones, and just by looking at that, you really don't know what's happening. So you basically give a meaning. But if you really dig deep, that zeros and ones has a structure, unique structure.
That structure is defined, and so what we've done is with the Bridgeport bridge, we wrote code that takes those zeros and ones and parses them in a specific way and ascribes a specific meaning to those transactions. In this case, messages being exchanged.
And it goes both way for viewing it and also like putting it on chain as well. So I think I understand now. I'm actually interested in this this one that you have here, the Scratchpad. So basically, is it just you're sending
you can just create any transaction you want, basically. Well, it's not quite that advanced yet, but Scratchpad Studio is it's a Babbage app that you can use. So the transactions that are created by Scratchpad, because they are custom transactions, it's not necessarily hooked up to any specific Bridgeport bridge, right? Like I'm just creating these transactions and sending them out. I can create transactions using Scratchpad that comply with a specific Bridgeport bridge, but that's just a generic like interface into Babbage Desktop. So like there's a function in Babbage Desktop called create action. And that function you can pass in, what outputs do you want in your Bitcoin transaction? What inputs do you want to spend? What is the fee that you want to pay? What are the keys you want to use to sign the transaction, etc. And so Scratchpad Studio is just like a user interface on top of that allows you to kind of use the create action function to like send transactions that contain certain data outputs. And that can be used to create things that comply with particular Bridgeport bridges rules, but it's a very general thing. It's a very basic app that doesn't leverage any of the Bridgeport stuff. And by the way, I'd want to mention that Convo Messenger is completely open source. So anybody that wants to look at Convo Messenger, fork it, make their own copy, compete with me, and also the Bridgeport bridges associated with Convo Messenger they're examples and they're completely open source. So if you want to make a Bridgeport bridge, there's some really good examples for how things can be done. And that's on GitHub. Like that's, open BSV license. If you're building on BSV, like go ahead, build that, build that stuff in whatever way you want.
Yeah, because and this is really interesting, and I really appreciate your time for this, because all of these I'm not a developer. I have developed a few things back in the day, but I'm not really a developer. So, but I do understand the whole picture, and how we could leverage towards the vision of going back to the phone again, how we could leverage this, like these things that we build, like Scratchpad and the Convo messengers, and in the future more apps, and how we can incorporate these. I think that's where I come into the picture, and I understand that, and that's I think that's really important, because especially with the open systems. And that's what incentivizes the Bitcoin, really incentivizes people. Like, you build things on top of it, and you gain value, I gain value, all of us gain value, right? So the idea is to build more things on top of the protocol itself, and then more things on top of the overlay networks, more things on top of the apps, and then just keep on improving and adding more value. So
you're competing on user experience, so you're going to get good user experience.
Yeah, definitely. So talking about this Scratchpad, so I just want to see how this really works. So say when it says private key, am I just doing a private key?
So Scratchpad is a way of creating Bitcoin transactions that are signed using, in some cases, an RPuzzle, in some cases, a private key. And so you can, if you want to sign an RPuzzle input of a transaction using a specific private key, perhaps because a certain protocol requires it, then you can actually have the transaction be fully, funded and paid for by Babbage Desktop and the funds that are in your Babbage Desktop account. But it's also signed with an external private key or a key that you choose. So you have a lot of flexibility to create the kinds of transactions that you want to create. So you can just randomly generate a private key. I think there's a little dice icon or something, or you can just randomly generate one.
So if I do that,
but that's the private key that's going to sign that transaction.
Okay, but that's not going to have a fund because if I need for
no, it won't. It's just a random key.
So so if I want to add some OP return, say today's date, Ty and Samir's conversation. I'm just putting some messages here. And I just put a date here. 11:30, 2021, 11:21 p.m. EST. Okay, so now when I say add, what does that really do?
You're adding an output to the transaction, which contains that op return. And what you're doing is actually, if you hit add, I think you're adding another data element to the op return output. So you may not want to have two unless you have multiple things, but different protocols can do different things there. And then with that private key, so Babbage Desktop uses RPuzzle, UTXOs. So every RPuzzle UTXO can be signed using a private key that you specify. So if you don't really care, you can sign with a random key. Now that doesn't necessarily mean that all the inputs and outputs are untraceable because they're in a graph and because the K values, are still part of the equation that you can kind of check what the R hash is and all that stuff. But
so now if I broadcast it, it's gonna ask for, it needs some fun because it just won't be mined. And where
it's saying, would you like to? Yeah. So you have a number of Satoshis in your Babbage Desktop wallet right now that happen for free because when you make an account, my faucet, because you have a unique phone number, gave you some Satoshis for free at the beginning, right? And that way you can create your first actions on the MetaNet for free without having to pay until later. And so it's asking if you'd like to spend some of those Satoshis that you got to create this action that you're creating, which would be, putting this data on chain.
So I actually probably spent all my Satoshis in the Babbage app. So let me send some. So where would I send this to? I don't have a.
If you go to your Babbage Desktop, you'll see on the top left you have a pay mail under your profile photo.
Yep.
And you can copy that pay mail. Hand cash, I wouldn't recommend. I think Money Button works better.
Okay.
But if you use Money Button to send yourself some more money, you'll have enough Satoshis.
I don't have I only have hand cash. I used to have Money Button. I don't use it anymore.
It's because and if hand cash watches this video, the reason why is because when I send with hand cash, they don't allow P2 RPH outputs in the when you request outputs for the P2P transaction. So that's why hand cash doesn't work. It's because they're not extensible enough in terms of the custom scripts they support for transaction outputs. So that's why, but that's not really relevant. In this case, I would just say that Money Button is the best option for funding. In the future, what's going to happen is you're going to get a pop-up and it's going to say, hey, you don't have any more Satoshis. And it'll allow you to buy some with a credit card, verify your identity, etc.
Actually, you know what? It did work. I actually was able to send some Satoshis using my hand cash.
You were?
Yeah.
Oh, well, I'm glad they added support for custom output types for Paymail. So that's good on them. I'm happy that worked.
Okay. Yep, it did. So yeah, I think you your system works much better than That's a good thing. I don't say that more often. Often, but it seems like your system works.
It's going to work for what people make it work for.
Yeah.
I hope that I hope people build cool things. That's kind of my thing is like, if people have an idea for an app, like think about how you can create a Bridgeport bridge that defines your protocol and put your data on chain. Like, what are the benefits you're going to get out of that? What are the benefits your users are going to get out of that? You can monetize in different ways. You can do all of this stuff. It works. This is the MetaNet. This is not some ambiguous idea. This is code that exists right now that functions and that people can use and get tangible benefit out of. So I'm working
So,
with some people to build some cool things.
I'm trying to use the Scratchpad here, and
Mhm.
so when I go to the app, the desktop, so App Explorer, App Catalog, it opens up a new page, and launch Scratchpad. So all the information about me of how many satoshis is there, it's already transferred to this one, or how does that?
So Scratchpad doesn't know anything about you until you give it permission to know. What
Okay.
happens is Babbage Desktop is running on your desktop computer,
Yep.
or your laptop computer or whatever, Mac OS, Windows, or Linux. And so Scratchpad will send a request to Babbage Desktop, which is going across, it's an inter-process communication between the different processes running on your computer. And Babbage Desktop, it's like a question and an answer. So first thing that Scratchpad will say is anybody logged in? And if no, then Scratchpad will show that little icon that says you must launch Babbage Desktop before you use Scratchpad. If it says yes, then that's like a very basic question. So we just kind of answer it without letting the user have permission to say whether he's logged in or not. But you can't really learn like, okay, what's the user's name, pay mail? Well, you can't use it to encrypt or decrypt anything until you grant access. So when you first launched Convo Dark, you got a pop-up and it said, well, Convo Dark would like to access a certain data in a certain key of yours. And you had to say grant. So it's the same type of thing here, where until you grant permission, and by the way, it says numbers and letters right now for the key, but eventually that will change to a human readable name. So it might say Convo Messenger would like to access your messages, or your on-chain messages or something.
So I just opened up Scratchpad. I put some messages there, created a new private key, public key pair, just pressing on that right in that icon there, and I did broadcast, and it just has been waiting here.
Do you see a pop-up that's asking for authorization
no,
from
it
Babbage
didn't.
Desktop?
No, it didn't. I'm using Chrome. I don't know if that matters, but
okay. I would try to refresh the page or something, but I mean, this is all really early. I think that most of the stuff works all right. If there's an issue, it should ask for authorization. It should say,
okay,
Scratchpad is requesting to spend a certain number of satoshis, and it'll give you like a blue allow button and a red deny button or something.
Okay.
But maybe relaunch Babbage Desktop or refresh Chrome. But yeah,
Okay.
all this is pre-alpha at this stage. I mean, I'm literally, and this is sometimes hard for me to believe as I look at all the ramifications of all this stuff, but I'm literally the only person that has built, I built Bridgeport, Babbage Desktop, these example applications,
Yep.
And things like that. But I'm hoping to expand in the future with bringing some more people on board and things.
Yeah, definitely. You know what? I would like to mention this because we are setting up a I'm from Nepal, and we're setting up a team there in Nepal as well. Just building basic IT stuff, but we want to train these guys with blockchain, and we're
Right.
having the BSV Academy, the training materials and so forth. But down the line in the future, once we have these guys up to speed with blockchain development, and I'm definitely gonna have them go through your blogs and your like projects, so they get the familiarity. But in the future, if you at all need any help, let me know, because I'm interested to work together. And like I said, this isn't, we're doing an open system where everybody contributes. So I'm really open to like working with you and helping you out as well, because a lot of visions that you have, it aligns with how I think as well. So we kind of have like a similar visions in terms of what we're going to build. So I would love to help you out. And
I mean, I'm really I want to get as many developers as possible to build apps in this way and to understand this way of thinking about how apps should be built. Because the more developers, the more apps, and the more apps, the bigger the network effect. Because every user of one of these apps is also a Babbage Desktop user. So they're going to go check out the other apps. And that means that the developers have a real chance of earning money from having people that are just new, that are coming to the platform and saying, oh, cool, what's this? I'll look at it. I like it. Maybe I'll pay a little bit to watch this movie on a streaming platform, or to interact with this artist, or to to do whatever on a social network, like on a value network. For the first time, a social network on the internet can actually be a value network, and that's really powerful. So I hope to see as many people as possible doing things. And the cool thing is, like, I know that Shamir, like, you and I don't necessarily agree about everything. I don't think we agree about, like, the what is it, Keynesian versus Austrian economics or whatever. But the point is, I mean, like, we can still build on this common platform. We can still create things in this way. And, like, the best apps and the best economic models and the best ideas for how people can get the most value out of the services they use are going to be the ones that succeed. And that's something that everybody does when they vote with their dollars and with their minds and with the ways in which they spend their time. And to all the developers out there who are looking to create things, I mean, I have the question for them: which way of building do you want to be part of? Do you want to build for the advertising model, or do you want to build for the model that maybe is more value centric, that allows people to get more value out of the things that are created? And so everybody has to make that decision. Everybody has to choose how they want to live, and also what kind of world they want to live in. And they express that choice by the things they buy, the services they use, and the ways they spend their time, the things they spend their time learning about.
Yep,
so
definitely. Definitely. And I think I fully align with what you have and I think we all align with the Bitcoin, the principles, and I think that's where there's a common ground there. And I think I fully agree with you that we are kind of building on a similar principles and so forth. And funny you mentioned that about Keynesian Austrian. I do believe in the Austrian economic model. I believe in savings culture, but also at the same time it's really a
balance.
Exactly. I do also think that there needs to be some kind of balance, and ultimately over time I think there would be a need for that Keynesian model at some point in time down the line. Not
it's
right away.
It's a spectrum on top of which debates can happen, and markets can kind of decide between the two models of how you want to have a market.
Exactly. I think there needs to be a balance on both sides, because of course if we onboard every 8 billion people onto this platform and have everybody has some sort of ownership of UTXO,
their MetaNet identity, right? Their on-chain descriptor for
exactly. And I think that will work as well, but at the same time I don't think that's really practical. It's not going to be there. There will be even like half or more than half who would who would want to be on the other side, who would want to have that. Right. And so I think there needs to be a balance. So that's what I was mentioning. I remember from our I don't know, couple of meetups ago we talked about on this, but but at this point in time I do believe the balance has kind of shifted towards we need more of an Austrian economic model for us to move forward, and I think Bitcoin provides that. I think that I fully agree with you. So so I think this is great. I'm gonna do some more reading on what you have here, and do you I'm just curious, do you happen to have like knowledge on the hardware and like microprocessors, and because ultimately how do we start incorporating these apps into those like
how do we get devices that
devices
way, like operating systems and
exactly
things at low
so
levels.
have you thought through those lenses, or do you have any idea?
I know JavaScript.
Okay.
That's but all. What I can do with JavaScript is, I wrote the Computing with Integrity paper on openstandards.cache. And that is where I define a file system. And so with that file system, you can define common, a .js file, and that file system is a script that can run, and you expose certain globals, and you can get a deterministic architecture to exist even just on top of JavaScript or whatever system you want to use. So my way of going about that is probably not going to be as in depth. I don't know how an ALU processes arithmetic logic unit inside of a processor performs its arithmetic. I don't know how it does all of that stuff.
Yep.
I can't run the NAND to computer game forwards and backwards in my head as I'm thinking about how all of these things are supposed to work.
Yep.
So I'm not one of those guys. I don't have all of that knowledge. I just know JavaScript. And
Okay.
but I do think that there's going to be room for a lot of that specialization to happen. And I want to see the bridges that people build in terms of how do we view Bitcoin in that way, because that would be really cool.
Exactly.
If we can get Bitcoin to run in that particular way with all these low level instructions and, Turing tapes like Chaohui built with the Bitcoin is Turing complete smart contract, where he literally put a Turing tape in a UTXO and tracked its state and all of that stuff. Like, that was really cool. So
yeah, definitely.
And the Wolfram 110, I think it was, or I don't remember. I think that's what it's called. Those sorts of things, like a lot of that stuff is not going to be me. I'm not going to be the one to build every aspect of the system, but what I do want to do is make sure that people understand it, make sure that it does get built by somebody. And if somebody else isn't going to do it, well, then they leave me no choice. I'll have to do it myself. But
exactly.
I really do think
my skill set is trying to understand I understand the whole picture, the complete life cycle, and also the other skill that I have is trying to get the right person to specialize, specialized person who has the knowledge of the that particular piece. So, and I can put together a team where where we all can work together.
Each of the people have their function.
Yeah, exactly. So I've been doing a lot of searching as well. So maybe down the line, if I come across that individual who might be able to assist us in educating how the core, the hardware part really works, and the microprocessor and all that works, then we might be able to create a bridge, or being able to communicate like your JavaScript and how can we put them all together. So I would love to do that, and I think I'm still working on it, but I think this is great that what you have built so far, it is really, it's so workable.
It does work, and it's there. It's code that exists that will run these state machines. It will make them run. So I'm happy about that, and I hope that many people for a long time continue to run state machines and Bridgeport bridges and things on top of Bitcoin. I think that's what's going to happen, and I think that's going to run the world one day, actually.
Definitely.
That's a big thing to say, but I think that an auditable and replicatable view of history is something valuable, and I think most people want that because most people are honest. And if we build that with Project Babbage, then I think we got a shot at doing some really cool things over the next few years and decades. So we'll see how that plays out. But I definitely, in terms of bringing together a team, that's what I need to be doing. I was doing some work last week, and I thought to myself, this is very low level. I need to be at the high level. I need to be putting the pieces together. I need to be delegating this type of work to somebody else, to another person who can specialize in Nano Store or Bridgeport or the UTXO Dojo or the CWI kernel that runs inside Babbage Desktop and manages permissions, or the file system, or all of these different components. Like, I have 93 repositories on GitHub that are just various Parapet, Bridgecast, the Bridgeport Orchestrator, the Bridgeport Ingester, the Bridgeport Gateway, Bus Driver. All these are tools that do various very, very critical things inside the system. And they all need to work. It's like building an engine, only it's like building an engine that creates, it's like building a robot that creates robots or something. So very, very complex, but I'm happy to, talk in the future about things like that, and partnerships, investment, and all of that stuff definitely needs to happen. So,
definitely. And I think the way I see, when I see your work and when I see you, I think you definitely understand the whole picture as well. You have a
Right.
vision, but also at the same time you have a very low
I mean, I'm ready to
understanding of
accelerate this.
exactly.
I need to get people involved so that this can be accelerated. And that's
Yeah.
where I've been shifting my focus towards, let's see what I'm willing to consider in terms of investment and people involved in that regard. And
Yeah.
so, I'd go on the record as saying that like there are some things that are starting to, there are some wheels that are starting to turn.
Mhm.
And I think this is about to go into the mainstream in a big way. And I think that's what the real future of Bitcoin is, because everyone's running around saying, oh, this, Craig Wright case and all of these things, NFTs, buzzwords, hyper ledger, all of these things. But what is the real future of Bitcoin? Where are the real tangible benefits that people care about? I think people care about privacy. I think they care about value. And I think that, enabling them to interact with each other in better ways and convey value in better ways is something that most people can get behind. So that's what we should be working on building. Definitely, and, definitely. Happy to do everything I can to make those things happen. So, I think I'd leave it there.
Yeah, definitely. Yeah, definitely. And I think I don't want to keep you too long. And maybe I don't know if I've asked you this question this last because I've been doing a survey within the Bitcoin BSV network. I don't know if I've asked you particularly, but the section 7 of the white paper reclaiming disk space,
reclaiming
right?
disk space.
Yeah. I don't think it's a problem right now for the miners where it's not as huge as it can be in the future, but over time they would want to reclaim their disk space, and there might be a business with that, right? So any transaction that's happened on the Bitcoin network, and anything that you attach to it, like all these applications are going to attach all sorts of data,
they're going to ascribe meaning to those transactions.
Meaning to it, yes. So if there's a way we could collect these transactions and it's Merkle proof, and I don't know if even tokenize it in some form, and then start creating a business out of it where you just where we can just send these transactions or trade these transactions over, and it stays in multiple SPV like user networks, right? So user clients. So any transactions, it's not only now stays in the miners. If they wanted to claim their disk space, they can distribute out as a business to multiple SPV clients. And SPV it's going to be small, and people can just store their own transactions with themselves, or they can even distribute that to over like distribute over, right? So I don't know if you see any value to it, but I do see some value in that. So if there's a way we could start building that, I don't know what needs to be done at the low level, but
the first thing I would say is I'm glad you said that you did a survey of the people who are around the BSV network, and not the BSV community. I made that distinction, and I'm glad that you've begun to make that distinction, because it is a very important distinction. But what I've described with Bridgeport is the way that not only will we preserve the transactions that people value, we will also preserve the meaning that has been ascribed to those transactions, and therefore we will preserve why those transactions were significant when they happened. And those preservations will happen for as long as people are willing to pay Bridgeport nodes to run the bridges or to host the bridges that contain that data. And so maybe one of the protocol rules is that after 10 years, it gets deleted out of the database or something like that. I don't know. Maybe that will happen. Maybe it won't. The market will decide on those aspects, right? So there's a 500,000 block window, and everything that's like earlier than that window needs to be resent as a new transaction if it needs to be preserved for longer than that or something. But that's on a bridge by bridge basis. That's on a view of Bitcoin by view of Bitcoin basis. And so in terms of allowing miners to reclaim disk space, I think the miners should keep probably just the UTXO set, and Bridgeport can be set up to track things that people find valuable, the significance of the transactions that people have made, and also the state associated with that, the meaning ascribed to that data in compliance with particular protocols. And you store the Merkle proofs with it so you can prove it later on. And if anybody wants to buy that from the Bridgeport node, so suppose I'm a Bridgeport node and I happen to keep all cat photos that were ever sent on chain because I wrote a Bridgeport bridge that filters out, I don't know, photos that get run through a certain pre-trained neural net that very deterministically decides whether it's a cat photo or not.
Yep.
And that neural network has already got pre-coded values. So it's like you can run it on every system, and every system will always decide that a certain thing is definitively or is not definitively, according to this neural net, a cat photo. Anyways, I write a Bridgeport bridge that does that. And then in 100 years, if one of the Bridgeport bridges or one of the Bridgeport node operators still has that data around, and there happens to be a lady that comes along and she is a cat lady, and she really wants to have every cat photo ever, she could pay that Bridgeport node to provide that particular data set. And that Bridgeport node could make money for holding on to it. But it's a market. Like you said, it's a market. If I, as a Bridgeport node, hold on to data that nobody cares about because I think they care about it, but they don't, and I'm wrong, then in the future, nobody's going to pay me for my trouble. And so I've lost. But if I hold on to something that everybody else thought was valueless, but it turns out some art collector or some historian actually wants in 100 years, and I held on to it all that time, and I was right holding on to it, even when everybody else was wrong, I got something valuable there. And I can make money. I can capitalize on the holding on to these things that nobody else held on to. So miners should reclaim just as much disk space as they are going to make, as they think they're going to make money in doing. And the ones that reclaim the correct things and get rid of the things they deem worthless will, they will be able to reap the economic benefits or drawbacks of doing that. So what happens is the miners with the best sense of value are the ones who are going to make the most money, because if I have a good sense of what other people value in terms of, I'm going to keep this around because I think it's valuable and other people also think it's valuable, they'll pay me for it if nobody else thought it was valuable. It's a market like you described. It's not a token, but I pay you because you did something or you held on to something that I wanted. That's how I think that's going to work for Section 7 in the very long term.
And one way that I'm thinking is like, if I, because we're talking about microtransactions, right? So when we talk about microtransactions, I want to limit, not limit technically, but when I'm sending this transaction and I'm attaching some kind of data, I want to have minimum data or distribute it over to like multiple sections, right? So so instead of sending a whole web page, I want to send like small chunks of this data per transaction. So that way I'm each transaction is, instead of having one transaction having more value versus the other, every transaction kind of like has an like a same value, because that's how I design my my process.
You can create what I would say is that goes into implementation details of how we're going to do a file system, how we're going to do data exchange, how we're going to do web pages and things on chain. I have ideas around that, but what I would say is that whatever protocol you come up with for doing that stuff, whether it's hashes, whether it's putting everything in operturn, which I don't recommend because it's giant and expensive, or what have you, create a Bridgeport bridge for it and make that way of viewing Bitcoin if you think that's the best way to view Bitcoin. But the reason why I don't offer a specific opinion about that is because I think there's different ways of doing it, and I don't want to endorse any particular way, because I want people to experiment. I don't want people to think, well, Ty says that's the way to do it. I mean, just like how Craig said, well, I'm not going to tell you how to do tokens, because then you're going to go, oh, Craig says that, or Satoshi says, in the worst case, that this is the way to do tokens. And so, this is the only token proposal endorsed by, yada, yada. So for that reason, different ways of doing things, and we can view Bitcoin in different ways, but that sounds like something that you might be able to get somewhere with.
Yeah, because the reason I bring this up is like when you mentioned, say for example, there's going to be some transactions that's going to be more valuable than the other, because I'm already thinking along those lines of stable value tokens, right? So every transaction has is if could be tokenized with the Merkle proof attached to it. But if one transaction is more valuable than the other, then it doesn't really make sense. So the way to make it equally valuable is to reduce the size or maybe the amount of information that's
split it
in
up
it.
or something.
To split it
I
up.
see what
So
you're saying.
so instead of having a whole web page, which is going to give you, and also by doing that, we actually maintain privacy, because it's going to cost it's going to cost somebody to put them all together. And it's just, as you separate them out, that means like it's going to be more private, because like say for example, my identity on chain, if I put them all together, my photos, my name, my address, everything in one transaction, then people can, just by looking at that transaction, people can know everything about it. But if I put my first name, my on one transaction, my second name on the other transaction, then for somebody to come up and put them all together, it's going to cost them more. Just like how the economic system really works.
I see what you're saying.
So
I see what you're saying. So, I would just leave it to the market to decide on that. I'm not sure that that's correct. I mean, if you have a hash of 1 petabyte of data, and that hash is 32 bytes inside of a transaction, then all that data is kind of available because it's in that one hash. And so you can encrypt to have privacy just as much as you can split things up. So you could split it up, you could encrypt it, you could have a hash, and then have, nobody knows that hash except for you or something. Different ways of doing it, different ways of viewing Bitcoin. And, I have some ideas. I'm going to try to build some things in some ways, but I don't want to preclude others from doing different things. I see what you're saying, and I think the market will kind of coalesce on what people find most valuable in terms of factoring in privacy, as well as transparency, auditability, all of the factors that people find most valuable. Like Jordan Peterson was talking about, well, what is the highest value? What is the highest thing that is most and that's a really deep question, but I would argue that whichever one is the highest, it is some combination of different values. You mix things together to arrive at there is no single thing that just is that is going to outshine everything else so much, whether it's truth or love or beauty or whatever the case is. The point is, people factor in a lot of things when they figure out what is value, when they arrive at a price for an item. Right? When I price something, I'm factoring how beautiful is it? How true is it? How much do I love it? How much am I willing to receive in order to part with it? Because of sentimental value, because of all of these different things. What is the demand? What is the supply? All of these things. So the point is, people are going to do different things, and they're going to value things in different ways. And the market, if the people who are participating in the market are observing morality, if they are moral actors who are honest in their valuations of things. So as an honest person, for example, I would not pay a cent for ill-gotten, if I knew a bike was stolen, I wouldn't buy it. So therefore, if everybody was honest, then there would be no market for that bike because it's stolen. So moral actors inside the market and the value they ascribe to things will determine the best ways for protocols to be designed, the best ways for applications to run, the best experiences for users. All of these aspects of the system will work based on the things that people think are valuable. And so I think definitely. That, we'll see what people do. We'll see the kinds of value that people want in the world. That's going to determine what developers work on. Are they going to work on building another freemium ad-based thing with Hotjar and Google Analytics and all these tracking tools that spy on everybody and provide them horrible experience? Or are they going to build on the MetaNet where we can provide people what I think to be a better sense of value? And we'll see if I'm right. I mean, that's the question. And I think there's some reckoning that some people who are going to watch this are going to have to do. People are going to have to do some decisions about where they want to spend their time, how they want to spend their lives, what kind of world they want to have. And hopefully we can, I know what kind of world I want to have. I think that's pretty clear based on the things that I've built and the time that I've spent and the sacrifice that I've made to make this stuff happen. But we're going to see if that's a worthwhile pursuit or not, based on what other people decide, and based on the the values that people hold.
Yeah, definitely. I fully align with you, and like I said, I haven't. I'm just brainstorming all these, these ideas in this thought process, but I haven't really, put anything out there for me to really know what is accepted, what people really want, what that thing is. It's just all in my head right now, and I've been doing, like I said, I've been doing some survey, just a informal survey around the network and community, and actually both community and the network, and just to see, okay, what ideas should I really pursue right now? And of course, I do have a long vision as well that we can build on top of Bitcoin. But right now, we all have to start somewhere else. Somewhere small.
I mean, everybody has to decide what they value. You can't really look to others to arrive at a sense of moral value. You have to decide what is the best way to spend your time in order to pursue what you think is the most valuable thing. Yep. And you can't find that from external sources. Sure. I mean, you can try to get appreciation from people or do the things that they think you should do. But if you're not doing that for yourself, then you're never going to feel as though what you've built is the most harmonious with your sense of morality and value and everything else. Yeah, that's a decision that you can't look to the outside world to make. You have to know for yourself, like, this is what I think. This is what I feel is valuable for me. And, can't do it for approval. You can't do it because you think everybody's going to like you and think you're cool. I think that there's a lot of people that are going to dislike me and think that I'm uncool because instead of spending my time in high school, going to parties and all that sort of thing, I spent my time learning how to write code. But that's how better systems get created, and that's how that's how I live my life, is by what I think. And I can only encourage other people to do the same, because that's the way that we're going to get the most happiness. Everybody will get everybody is going to get their most happiness out of a life in which they do what they think is the best thing for them. They serve their own sense of value and of interest and of duty and of respect for others and justice and all those sorts of things. Like, that's a philosophical thing. But at the same time, we can't really defines things.
Yeah, but at the same time, we can't really ignore the energy on the surrounding that really kind of like defines us as well. Of course, it has.
You can't ignore it. But you can try to set it right. You can try to say, look, this is my contribution. This is what I think, and this is how I'm going to show what I think, and I'm going to live and lead and love and build all of these things this way. And other people can see that and they can accept or reject, but that's on them.
I think honesty. I think Bitcoin, when Satoshi mentions honesty, I think that is really key. Like, if we can be honest with ourselves and with all the, it's in every energy that we convey. We are honest. I think that kind of like give the energy out, and then people just accept it or reject it, doesn't matter, but all we can do is be honest. I think that's let's end with that today. And I would love to do this similar conversation in the future, just to have like when you're building anything new, and you want to just have somebody just to listen to, let me know as well, because I would do the same, and we can have like philosophical conversations.
I'd be happy to talk about things, and we can definitely do this in the future. I think it's been good.
Okay, cool.
All right. Yeah.
Cool. Well, thank you so much. And and I'm gonna look deeper into what you have built in Project Babbage. In fact, I'm actually in the GitHub, and I can't really see the Slack. What do you call it? Not the Slack. What's that?
Convo.
No, the Scratchpad.
It's on github.com/p2ppsr/scratchpad. One word. But I just read a URL out loud. So
can you say that again?
The best way.
Can you say that?
GitHub.com/p2ppsr. slash
github.com. Once I can't type fast enough. P2PR
P2PPSR
PPSR
slash Scratchpad, one word, and that should be the repo for the Scratchpad broadcasting.
Okay.
Oh yeah, the source code for that should be available.
One second. GitHub.com P2PPSR slash SCRATCHPAD.
Correct.
.com.
Not .com.
Okay. You know it didn't.
But if you just go to my GitHub profile, you can find it. It's probably like on the first or second page.
P2PR repositories, right? Pages 1. And
if you see Scratchpad anywhere in that list,
I can't really find it. You know what? I can't find
maybe
it.
It's on page 2. I'm not sure. There's lots of repositories, but
I looked at both page 1 and page 2. I can't.
Maybe that one isn't open source. I'm not sure. If it isn't, it's by accident. I should open source that app. But
okay. Yeah, because I'm interested to look into that, and that's built in JavaScript as well.
That's all built in JavaScript. That's a React app. You can look at Convo too. I think Convo is.
Oh yeah, I see. I do see the Convo. But yeah.
Is this something that exists? Yeah. So this is it is private. Okay, I'm going to make this public right now. Okay. Because I want this to be open source. Okay, that would be cool. Well, I'm not going to do it now because I have to update the license and get rid of some proprietary dependencies and stuff.
No worries.
But yeah, that Scratchpad should be open. You can look at Convo, and there's also some demo stuff. Like there's Babbage tutorial. Yeah. There's Babbage React Starter. That's a good place to start. There's Babbage Hello World. Yep. There's lots of documentation and tutorials. Everybody can go on projectbabbage.com and check out the stuff and shoot me messages. I don't want to get too overwhelmed by all these things, but hopefully I'll have a team to manage it eventually.
Oh yeah, no worries. Yeah, I'm gonna look into it more, get more familiarity, because like I said, I think your visions, what you have ultimately to be built on Bitcoin, does align probably not only with me, but with a whole lot of folks in the Bitcoin.
I mean, the internet is deeply flawed and completely fragile right now, and we need to rebuild it on top of Bitcoin, and I believe that. Yeah. I mean, we've got major problems. Look what the internet is doing to our world right now. It's ripping apart our entire society by the fabric of society. It's turning friend against friend. Yeah. It's taking us down a very horrible path. Yep. And we need to figure out and we need to reevaluate what we think is most valuable. Is it diversity? Is it equality? Is it equity, where everybody has the same thing? Or is it meritocracy and individualism and specialization and character? Those are questions that we have to answer. And
I think there is no one answer. It's all.
There is no one answer.
And everybody should be able to pick their own. But I don't know how we can bring them all together and
right. I mean, we live in the same world.
Yeah.
So we live in the same world. So we need a time chain to unify us and unite us under one view of history that nobody can kind of contest. Yeah. So if we get that, then maybe that'll get us the next thing. And other than that, as every single person throughout every aspect of history has always said, the only thing that we can recommend beyond solving today's problems is educating people the best possible way for tomorrow. Getting them to learn all of the things that they need to learn. And, definitely. If we can educate people the best and get them to learn properly how to think and how to tackle the problems of tomorrow, then we'll be doing all right for ourselves, I suppose. So, definitely.
All right, that's what I have. That's a good high end note, and good night. And I'm gonna if I have any questions, I'll touch base.
Yeah, definitely reach out.
Okay, this was
good talking
great. Thank you. Thanks, Ty.
Thank you. Bye-bye.
Yeah, good night. Bye.